Hey guys, today we're going to be solving rational equations. We've been dealing with rational expressions, and now we're going to look at rational equations. We're going to start with the easiest. The simplest expression to solve, rational equation to solve, is a proportion. Okay, so first off, make sure you understand what a proportion is. It's just two fractions that equal each other. Okay, so like 1 to 2 is the same as 4 to 8. That's a proportion. Okay, now ours are going to have variables in it, but that's literally what a proportion is. It's just two fractions that equal each other. When you solve proportions, you cross multiply. If you look at what are called the cross products of this proportion I created, 4 times 2 is 8, and 1 times 8 is 8. So the cross products are equal to each other. So this equation with no fractions is equal to this equation up here that does have fractions. Okay, so if I'm given a problem like this, I want to cross multiply. So the 4, and it doesn't matter which way. If you're looking at the x plus 4 times the 4, and so you write your answer here, or if you put 4, if you want to kind of distribute the 4 into this expression so you kind of feel that it's on the right side, it doesn't matter. Just be consistent so you don't confuse yourself. Okay, but 4 times x plus 4, I'm going to go ahead and put it over here, is 4x plus 16. When I multiply this direction, I'm going to get 8x minus 32. So if I subtract the 4x from here, I'm going to get 4x. If I add this 32 to the other side, I'm going to get 48. And then I'm going to divide both sides by 4 and get x equals 12. Okay, so again, what we're claiming is that 12 minus 4 divided by 4 would be equal to 12 plus 4 divided by 8. Well, 12 minus 4 is 8, and 8 divided by 4 is 2. 12 plus 4 is 16, and 16 divided by 8 is 2. All right, so that works. All right, how about the next one? You know what? Why don't you do the next one? I'll work it, but I'm going to stop talking. All right, so if you're not done, pause it. If you are, take a look at the solutions that I got. I got 5/3, and I got -1 as an answer. Now, I'm going to be honest, the 5/3 is going to be a little bit of a pain in the butt. To check the -1, let's go ahead and check the -1 and see if that works. So if I put a -1 right here, I'm going to get -3 plus 3 over 5 is equal to -1 plus 1 over, what's that, a -1? All right, so this is 0 divided by something equals 0 divided, so yeah, it's just 0 equals 0. Okay, so those are going to work, no problem. Okay, that answer works. If you want to check the 5/3, go ahead and knock yourself out. Okay, now, next one. Now the next one, again, for this one, when we cross multiplied, we ended up with a squared term. So I had to treat that like a quadratic, had to move everything to one side, factor it, and find the solutions. I can tell the same thing's going to happen over here. When we cross multiply this way, you're going to want to go ahead and multiply that out, FOIL it out, see what you're going to get. When you multiply this, you're going to get, let me go this way. So 4x minus 4, and this way it's going to be x squared, and then it's going to be a minus x, and then a plus 3x. So I'm going to have a plus 2x, and then the 3 and the -1 are going to multiply. Okay, so make sure you FOIL. If you need to rewrite that as a problem, as a foiling problem, and then FOIL it, that's fine. Okay, what do I have here? I have a quadratic. I'm going to move everything to the right. I already had a 2x. I'm subtracting a 4x, so that's negative 2x. I have a minus 3. I'm going to add 4 to that, so that's going to be a plus 1. Alright, so this is going to be x. Factors of 1 that add up to negative 2 are going to be minus 1 and minus 1. So my solutions are going to be positive 1 and that's it. Okay, just x equals 1. Now, check that answer. So if I put a 1 up here, I'm going to get 1 plus 3, which is 4. But then I'm going to get 1 minus 1, which is 0, which is not good. Okay? Same thing happens on the other side. So the two sides do equal each other. We did the math right, but we ended up with an answer that does not work. Okay? So since there was only one answer, now if we would have got two answers and one of them didn't work, we still would have been okay. But for this one, there are no solutions to this proportion. This is called an extraneous solution. It's an extra solution that popped up, but it doesn't actually solve our equation. So extraneous solutions are solutions that are obtained through proper algebraic means. Okay, we didn't do anything wrong. We did the algebra that we were supposed to do, but they don't satisfy the original equation. Okay, so this one had an extraneous solution. Why was the solution extraneous? Well, it's because in this case, not only the two sides did equal each other, but they created a 0 in our denominator, which we're not allowed to have. Okay, so why do you suppose that extraneous solutions can pop up in a problem like this? Well, if you can't think that through, let's take a look at some other problems. See if maybe as we do a few of these, we can kind of see, why are these happening? I can give you a clue, but it doesn't explain this one very well. So let's just keep going. All right. Before we move on, I want to take a look at an example like this. So this is the last problem you just did. Now we know that we ended up with an extraneous solution on this, but there is another way to get the solution. If you have a proportion and the denominators are the same, the only way the two sides could be equal would be if the numerators are the same. So if you know you have common denominators, then you can just kind of ignore those denominators, set the numerators equal to each other, and then just solve that problem. So this is the situation you have. If you have A over C, and that's equal to B over C, the only way that can be true is if A and B are equal to each other. So we could have solved this problem by simply saying, oh, let's solve x plus 3 equals 4. We would still get x equals 1. Now, that still would have been an extraneous solution that doesn't really solve our equation, but it would have been a faster way of finding it. All right, so again, let's take a look at the second page. Now, these are a little tougher. These are not proportions we can't just cross multiply. Okay, there's got to be another way to solve this. Again, I'm always going to try to show you the easiest way to solve things. And I handle these problems the same way I handled those complex fractions that we had to deal with last lesson. If I have a bunch of fractions that are adding and being equal to each other, what I do is I look at the denominators. I look at what would be the common denominator. I'm going to go ahead and make that a denominator 2. And in this case, the least common denominator between 3, 1, and 6 would be 6. If I multiply both sides of this equation by 6, so this side is going to get multiplied by 6, and this side is going to get multiplied by 6, that's fair. I haven't changed the problem because everything's still nice and balanced. But if I multiply 6, now I'm distributing over here, so 6 times x over 3, the 3 and the 6 are going to reduce, leaving me with a 2, and so that's going to be a 2x. Plus, that 6 has to multiply the 2. That's fine, that's 12. And then over here, that 6 and that 6 are going to completely cross-reduce, leaving me with x. That is a much simpler problem, okay? So if I subtract the x to the other side, I'm going to move the 12 to the other side, I'm going to get negative 12 as an answer. Okay, now again, we want to check our answers. We want to make sure we didn't get any bad answers. This actually is going to simplify pretty nicely. If you plug the negative 12 in where the x's go, so negative 12 over 3 plus 2 equals negative 12 over 6. All right, so negative 12 over 3 is negative 4. Negative 12 over 6 is negative 2. And sure enough, negative 4 plus 2 is going to give us negative 2. All right, so that worked. Worked out fine. No bad answers, so we're good to go. All right, look at the next example. Now, again, what I want to do is I want to multiply everything by the least common denominator of what I'm looking at. So I'm going to need to factor this so I can see what that is. I'm hoping that x plus 3 is one of these factors. So x, factors of negative 3 that add up to positive 2 are plus 3 and minus 1. All right, so our least common denominator is this. This has an x plus 3, this has an x plus 3, and an x minus 1, and then this just has a 1. This is just over 1. So if we multiply everything by x plus 3, x minus 1, then it'll clear all of our fractions. Okay, so again, I'm only writing it down once, but we are distributing it to everything, to both sides. So when this multiplies that x plus 3, the x plus 3's are going to cancel, and I'm going to be left with x plus 2 times this x minus 1. Plus, and then when this multiplies this fraction, the whole thing just cancels and just leaves me with a 1. That 1 that's in the numerator. The denominator is gone. Equals, and then when I multiply this times 1, well, I'm just going to have x plus 3 times x minus 1. All right? Now, to solve this, we need to open everything back up. So I'm going to FOIL this. This is going to be x squared. Negative x plus 2x is going to be plus x. And then minus 2. And then there's still that plus 1 right there. This is going to FOIL to give us this. Remember, that's where that came from. So this is going to be x squared plus 2x minus 3. Let's see what happens. I've got x squared. Now, in this case, when I move everything to one side, these x squareds are going to cancel. I'm going to move the x's this way because I have a 2x and an x. So if I subtract x, I'll get an x here. And now I'm going to add this 3 to the other side. Well, this is a negative 2 plus 1, so that's a negative 1. And I'm adding 3 to a negative 1, so that should give me a 2. Now, if I look up here, here's my original problem. If I put a 2 right here, I'm going to get a 5. I'm going to get another 5 and a 2. I'm looking to see if I'm going to get any zeros in my denominator. That's what I'm worried about. I feel like we did the math right. I feel like everything should work. I'm just trying to make sure we didn't end up with anything weird in the denominator. This, if I plug the 2 in, I should get 4 over 5 plus 1 over, well, what do you get when you put a 2 here? You're going to get 4 plus 4 minus 3. So 8 minus 3. So 5 equals 1. Well, sure enough, 4/5 plus 1/5 would equal 5/5, so that's 1. All right, so our answer works. All right, let's take a look at example C. Again, I've got a denominator. This is just over 1, so that's no biggie. But let's factor this. So that we can see what the denominator, what the common denominator is going to be. And this is what we have. I have a 5, and then I have a 5x minus 5. So this denominator contains all the factors that we see. So this is our common denominator. So 5x minus 5. All right, so when I multiply this by the first fraction, that 5 and that 5 are going to cancel, leaving me with 4 times x minus 5, or 4x minus 20 plus x times this as well. Now, there's nothing to cancel, so that x is going to multiply all of this. It may help us to remember what this originally was. It was 5x minus 25. This is what's going to multiply x, and so we're going to get 5x squared minus 25x equals, and then that multiplier is going to completely cancel that denominator, giving us 4x minus 50. All right. Whew. Let's move everything over here. I've got a 5x squared. I've got a 4x. Now, there's a 4x over here, so those are going to cancel, giving me minus 25x. And then I need to add this 50 over to here. There's already a negative 20, so I'm adding a positive 50 to a negative 20, so that's going to be positive 30 equals 0. Now, that probably factors, maybe, but first, let's factor out a greatest common factor. These numbers are way too big to look at. Let's factor out a 5. That'll give me x squared minus 5x plus 6, which is much easier to look at. All right, so 5, and then this is going to factor into x minus 3, x minus 2. So my solutions are 3 and 2. All right, so those are the solutions I got. Now, again, we need to go back and check those solutions and see what works, if they both work, or if nothing works. Okay, so I'm going to put in the 3. I'm going to put the 3 right here. That's going to give me 4/5 plus 3 equals, and if I put a 3 right here, I'm going to get 12 minus 50. So that's going to be negative 38. And then I'm going to put a 3 here. That's going to give me 15 minus 25. So that's going to be negative 10. And so right here, what am I going to get? It's like positive because the negatives cancel, and I get whatever 38 divided by 10 is. Now, at this point, I'm probably, as I'm looking, I was looking for a calculator. Okay, let's make our life a little bit easier on this one. So 4/5 plus 3 is, well, 3 and 4/5. Okay, I could have figured that one out. There's also a button that'll turn improper fractions into, so 19/5. So this would be 19/5, and hey, that's what this is going to reduce to. The negatives will cancel, 38/10 would be 19/5. All right, so that answer checks out. But what about the 2? Okay, if I plug in a 2, I'm going to get 4/5 plus 2, which apparently is 2 and 4/5, or 14/5. And then over here, I'm going to plug in a 2, so this is going to be 8 minus 50, that's negative 42. If I put in a 2 here, that's going to be 10 minus 25, so that's going to be negative 15. And what does, now, if you want to reduce a fraction in your calculator, don't put divided by. It's going to give you a decimal. If I take negative 42, hit the fraction button, and then type in negative 15 equals, oops, did I hit a negative? Let's try this again. Okay, let's just know the negatives are going to cancel. All right, let's type in, let's clear everything, 42 over 15. I think it wanted some parentheses around there. Again, let's rewrite this as an improper fraction, and we get 14/5 on this one as well. Okay? So, for this one, both of those answers worked. All right, example D. So again, what do I have here? I have, this is 4 times x plus 3. That's a 4. This is also 4 times x plus 3. And that's a 4. Okay, so 4 times x plus 3 is my common denominator. So if I multiply this times this fraction, I'm just going to get a 5. Minus. That 4 and that 4 are going to reduce, and that 3 is going to be multiplying the x plus 3 that I have. I could also think of this as a negative 3, and I could go ahead and kind of distribute it. That negative 3 times x is going to give me minus 3x. That negative 3 times 3 is going to give me minus 9. Okay, you just have to distribute it at some point. That and that denominator are going to cancel. Minus, and then that x, let's see, that 4 and that 4 are going to cancel. Minus x squared, and then minus 3x. All right. That 5 and that 5 are going to cancel each other. That minus 3x and that minus 3x are going to cancel each other. That negative and that negative are going to cancel each other. So I'm going to have 9 equals x squared, which means x equals positive and negative 3. Okay? Now, again, we need to check both of these. We need to make sure they work. So if I plug in a 3, if you plug in a 3 right here, you're going to get 12 plus 12, which is 24. So 5 24ths minus 3/4 equals, and then 5 24ths minus 3/4. And again, you can just tell that those are going to equal each other. No problem. But what about the negative 3? If I put a negative 3 in here, I'm going to get negative 12 plus 12, which is 0, and I can't divide by 0, so that is an extraneous solution. So x equals positive 3 is the only answer that works. All right, so why does this happen? Well, right here, if you look, we have nothing but x's. That's an x, that's an x, that's an x. Okay? You would expect when you have an x that you're going to get one solution. When you solve quadratics, you get 2 solutions. When you solve cubics, you get 3 solutions, etc. So when we multiplied, we ended up with a quadratic. So we did get 2 solutions. But we weren't expecting one of those, and one of those actually doesn't work with the rational expression that we're given. So we need to get rid of it. Now over here we got 2 solutions, and both of those worked. So there was no problem there, but over here we did get an extraneous solution. So you have to check your answers on these rationals. All right, let's go ahead and take a look at example E. Why don't you try example E? Notice that this denominator over here is going to factor into x times x plus 2. See if that'll get you started. And then pause the video, try to solve this, and hit play when you're ready to check your answer. All right, so I factored that. I realized that that was what I needed to multiply everything by. This has an x, this has an x plus 2, and this has both the x and the x plus 2. So I multiplied everything by that. The x and the x canceled, leaving me with 5x plus 10. The x plus 2 and the x plus 2 canceled, leaving me with 3x. And then all of this canceled, leaving me with negative 6. So I solved that equation. I got x equals negative 2. However, plugging negative 2 back into this denominator is going to give me a 0. So it doesn't work. We only got one answer. That one answer is an extraneous solution. So actually, no solutions is the correct way to answer this question. Okay? All right. Again, take a look at F. Why don't you see if you can just figure out what the common denominator would be, what you need to multiply by, and see if you can solve F. Again, pause the video. All right. So my denominators were x minus 2, x, and x. So all of that together, an x and an x minus 2 is what I would need to multiply through by to clear all these fractions. So I did that. I multiplied through. I got x squared minus 3x. And then I got minus, well, it was minus x minus 2, but I distributed that. And so I have minus x plus 2. On the other side, the x's canceled and left me with x minus 3 times x minus 2. So I went ahead and FOILed that out. My x squares canceled, and I solved, and I got an answer of 4. So looking, it appears that 4 is not going to give me a 0, but I still need to make sure that it works. So I plugged the 4 in. I got 1 over 2 minus 1 over 4 equals 1 over 4. Well, 1/2 minus 1/4 is 1/4. So that does check out, and that is my solution. All right, take a look at your worksheet and let me know if you have any questions.